Hello everyone and welcome to another AdMaths tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 9 Motion Along a Straight Line, Long Question Example 2. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. A particle moves in a straight line. Its displacement s meter from a fixed point O t seconds after leaving O is given by s equals to t cubed minus 15 over 2 t square plus 12t plus 10. So the question asks to find the nearest distance of the particle from point O, the value of t when the particle is at instantaneous rest, the total distance traveled by the particle in the first 5 seconds, the range of values of t when the particle accelerates. So these are the respective question, guys. Okay, we're going to start to discuss the solution for question part A. So let us begin. So for question part A, to find the nearest distance of the particle from point O, so we're going to differentiate the displacement with respect to time. So ds dt, and then we're going to set it equals to 0. Okay, this concept is pretty similar to find the turning point and then maximum minimum point, guys, in chapter 9 differentiation. Okay, if you don't remember the concept, please recall your differentiation concept, guys, especially in the turning point, maximum minimum point, okay, at that particular topic. Okay, continue to the question. So we differentiate s. So from here you get 3t square minus 15t plus 12 equals to 0. As you can see here, we are forming a quadratic equation. So this expression we can simplify by divide the whole quadratic equation by 3. So from here, t square minus 5t plus 4 equals to 0. So we can factorize this equation. So from here you get t minus 1 in a bracket, t minus 4 close bracket equals to 0. So from here you get two t values, guys. You get your t value is equals to 1 or t value is equals to 4. So you get these two t values, two possible t values where you will get your nearest distance of the particle from point O. So to double check which t value gives the answer, so what we're going to do is, so we're going to do a double differentiation over here. Okay, we're going to differentiate s again, which is d square s over dt square. So why we are doing this? Since we are required to find the nearest distance. So still remember the maximum and minimum concept. So when you differentiate 2 times, when you get more than 0, that means you're finding the minimum value. Whereas if you get less than 0, that means you're finding for the maximum value. Okay. So this is just to recall your differentiation concept, guys. Okay, let me turn to the next page. So please hold on for a moment. Okay, you differentiate your s with respect to t second time. So you get 6t minus 15 over here. Okay, since you have two t values, so we're going to substitute one by one to check which one gives the minimum value. Okay, so when t is equals to 1 second, so you substitute in d square s over dt square is equals to 6 times with 1 minus with 15. So from here you get your double differentiation value is negative 9. So negative 9 is less than 0, guys. So therefore you can know that when your t equals to 1, your displacement won't give you a minimum value but a maximum value. How do you know that? Your double derivative value gives you a less than 0 value. So this won't be the answer, guys. Okay, let us check for the t equals to 4 second value now. So when t equals to 4 second, d square s over dt square equals to 6 times with 4 minus with 15. So 6 times 4 you get 24. So 24 minus with 15 you get is 9. So 9 is more than 0, guys. So these conditions satisfy our question, which is we need to find the minimum point. So since your double derivative over here more than 0, So this point we can denote that it's a minimum value, gives a minimum value. So when your t equals to 4 seconds, the displacement produced is a minimum value, guys. So you can find the nearest point. Okay, once you identify this, you double confirm that this is your minimum value. What you do? Substitute t equals to 4 seconds in the displacement equation. Okay, so you substitute in s equals to 4 cubed minus 15 over 2, 4 square plus 12 times with 4 plus with 10. So you calculate everything. So you get your displacement is equals to 2 meters. So this is your answer, guys. So you should get your displacement is equals to 2 meter. Okay, let me proceed to the question part B. Okay, the question part B, they asked to find the when particle is at instantaneous rest. They asked to find the time. Okay, one thing you should know, guys, when your particle is at instantaneous rest, your velocity will be equals to 0. So since v equals to ds over dt, so 3t square minus 15t plus 12 is equals to 0. So you divide this by 3. Since this is a quadratic equation, so you can simplify this quadratic equation. So t square minus 5t plus 4 equals to 0. So from here, you factorize t minus 1, t minus 4 equals to 0. So from here, you get t equals to 1 second and t is equals to 4 seconds. So this will be your answer, guys. Okay, for question B. Okay, let us proceed to the question C now. Okay, for the question C, they ask us to find the distance traveled in the first 5 seconds, guys. Okay, to find the distance traveled, you can actually use two methods over here. One, which we are showing right now, which is you sketch the motion diagram and then from there you find the distance traveled. And another way is you find the area under the graph. Find the area under the graph, which means that you have to do integration. Okay, there is two methods over here. So we're going to look at one of the methods here. So step 1, what we do, we calculate the value of s for each of the following instance. So when t equals to 0, 1, 2, 3, 4 and 5, so we calculate the respective displacement. Okay, so you calculate this, you should get your respective displacement is 10, 15.5, 12, 5.5, 2 and 7.5. Okay, this is your step 1. Okay, moving on to the next step, what you do, you need to sketch the motion diagram of the particle. Okay, based on this given displacement, so you need to sketch the motion diagram. Okay, let me show you the motion diagram now. Okay, as you see here, your t is equals to 0. It start exactly at your displacement is equals to 10. It's not starting at the point O, guys. It's starting at here. Okay, t equals to 0 and t equals to 1. It's starting moving here. And then it's going back and then it's going in front again. So this is your first motion diagram at t equals to 1. However, at t equals to 1, it's starting to turn back until t equals to 4. And once it comes to t equals to 4 and then it's go back in front at t equals to 5. Okay, so this is your motion diagram, guys. Okay, I draw in this way so that you can imagine how your motion diagram will looks like. So it's easy for us to calculate for the next step, which is the distance traveled. Okay, so once you have already identified the motion diagram of the particle, so the third step what we need to do is we need to calculate the total distance traveled. So how to do that is it's very simple. So for the first motion, what you do, you calculate your distance traveled. 15.5 you minus with 10, so from here you get 5.5 meters. So that is for the first one. Okay, for the second one, it go return back from t equals to 1 until t equals to 4. So 15.5 you minus with 2, so you get here 13.5. so this is your second distance. And then t equals to 4 and it go back to t equals to 5. So 7.5 you minus with 2, so from here you get equals to 5.5 meter. So these are the respective distance, guys, from t equals to 0 up to t equals to 5 seconds. So to find the total distance traveled within the first 5 seconds, what you do, 5.5 you plus with 13.5, plus with 5.5 again, you get your total distance traveled is 24.5 meters. So this is your final answer, guys. So I hope you get the explanation clear. Okay, let us move to the last question. So when the particle accelerates, that means the acceleration should be more than 0. So how to find acceleration? You differentiate velocity, you immediately get acceleration, guys. So you differentiate velocity. So from here, you should get 6t minus 15 more than 0. So 6t more than 15. So to find t will be 2.5 seconds. That means your time should be more than 2.5 seconds so that your particle will accelerate, which means that your A will be more than 0. Okay, so this is your final answer, guys. Okay, let me put back the question paper for your reference, so please hold on for a moment. Alright, that is all for the step-by-step working and solution for this question. Okay, I hope you understand the working that I've shown to you. Thank you everyone for your support, and I will see you in the next video.